I'll make it go at a 10 thousandths and the speed of 228, and then a feed converted to metric of 0.25, and OK. Okay, so that gives us some calculations for in-mill roughing with carbide. And now, of course, if I take that and I right-click, copy it, and I go now to high speed, I can then paste those values into high speed. And then, of course, from here, I would make any alterations or changes I might for the settings. So I might go in and change. Now, let's just change this one a little differently. Let's do it with the graph method. So I'll go to the graph data, and then I can start with the very first one. I'll zoom this down a little smaller so I can see my values a little easier. So I'm going to go to this first one, double-click it. That's the first one that's set at 300. We're going to change this to half of that, 150. And we're going to change this to half of that, 0.000982. We're going to change this number to 46, and this one to 0.025. So we're basically going half the size there, half the feeds and speeds. Now, notice it didn't change. It won't change until I close this list here. So let's go to the next one. This one's going at 400. We're going to change that to half of this, 200. That'll make that 61. That'll make that end up being 0.0015. It'll make that one 0. So anyway, that takes care of the speed feed calculator, and you see how we actually are using it in our operations. Oh, one other thing, let's check the tapping real quick. Let's see what we get for tapping. Let's say I've got a high-speed tap, and let's go into the tapping, and let's tell it to, yes, let's use the calculator, and let's use tapping. And you see I've got 458 RPM, and you see the pitch it's getting from the tap itself. That's why I mentioned that when you're doing the tapping, when you set this up for tapping, don't worry about what these feeds are going to be. The key thing you're after are the speeds. And so what the speeds do is they enter in what the surface footage is going to be, and then from the surface footage it's going to plug in the pitch, and you will get the appropriate feed rate. So that's all you need to focus on with tapping. Now in the Security Manager, basically when you load it up, it's going to ask you to log in to edit. You log in, you give yourself a password. Now at first, if you don't have a password, just hit OK. Then you can hit change password and enter in a new password. Now, let me cancel all that. Now this switch is kind of the master switch that says whether or not you're going to use this Security Manager to manage the data in this knowledge base or not. And so by turning this on, you're telling it that you are in fact going to use security. Now what you do here is at the bottom is you can add your users. If you do a right click, you can say add a user. And then you give the user name as the name shows up on the network. So the actual login user name. Say it's something like Tom, for example. And then the default permissions for Tom. Do you want him to be have all permissions? We can read and write. Do you want him to read only? Do you want him to read and be able to update? Or you can read, update, and insert new material. So we hit OK, and what it does, it'll show you all 5 of these sections of the KBM, and it's basically giving you the option of being able to modify or change permissions for any of these. So I could say, for example, let's say the cutting tools will let the user change that data. But I might, on the speeds and feeds, not want them to change that. So I could go in and change the permissions to read only on just the speeds and feeds. So you can micromanage these permissions and get the permissions exactly the way you want for a particular user. And then from here you simply would add another user and manage that data, manage the information, access to that information for that other user. Through this method can seem a bit overwhelming because there are lots and lots of words and lots of information here. And that's why I've gone ahead and included a few documents that will help you with this a little bit. For example, I've included in the reference area of this tutorial a couple of the technical bulletins. One is a two-part technical bulletin called Express Yourself, which goes through and talks about different kinds of expressions and syntax that you might use. Fairly helpful, and there's some areas where it can really help you to understand how to do some of these equations, how to get certain values, and examples of how you can use them. And there's also a second companion, Express Yourself Part 2, which goes into even more detail, some other examples. And these are very, very handy to help you get used to getting information. Now, what I'm going to get information about is, if I scroll down to this second one, I see the use of a phrase, feature extremity. Feature dot extremity, open paren, ESPRIT extremity start, and then dot y. Now this phrase right here could be fairly beneficial to us, because what that can get us is it can get us where the start is in y of a feature. So if we look at any feature, and this is showing a turning feature, but we look at any feature, that feature has a start point, a middle point, and an end point. We know that already because we can get those properties in ESPRIT. If a feature goes all the way to the end, we know where it starts, we know where the midpoint is, we know where the end point is. And we know that in each axis. We know where it starts, ends, and middle of x, y, and z. So we see this phrase right here. This phrase can be beneficial to us. And if we look at that phrase, pull up another item that shows that phrase again, feature dot extremity, ESPRIT extremity start of y. Okay, so that's very handy. Now, well, we don't really need that information in y. We're trying to get that piece of information for z, okay, for the z-axis. We want to know where the extremity or the highest point is in y, and from the start of the feature. And so this is a phrase that we can incorporate, and we can actually even copy and paste, or I'll type it in again so we can understand this again, this phrase. But we can incorporate that in our drilling logic. So where we go to the full clearance, we're going to right-click, edit properties, and we're going to change the phrase that's in here for right now. We're not going to use the IM1 or 100. Now, we might use part of that, so I'll just insert in front of that some spaces here. And we're going to put in some logic. And what we want the logic to say is that if the feature extremity of z, the start point of z, okay, we want to make sure that we go an inch above wherever that is. Okay, so we can actually we can just put in that phrase. We can say feature dot extremity, open paren, and then we have that phrase called ESPRIT, ESP. Let me pull this back up so you can see it along with it. There we go. Right there. Feature dot extremity, ESPRIT, ESP, extremity start. So you can see that's what the phrase is going to go here. ESP, extremity start. And then the phrase says extremity start, close paren, dot, whatever axis you want to get that from, dot z. So the feature extremity, ESPRIT, extremity start z, plus, we can say the IM 1 and 100. So we say, okay, feature extremity, that value, z plus that number. Okay, let's hit our OK button. And now we have that logic is in that field. Let's go to Edit Properties. You see that logic now is in that field. We hit our OK button. It returns that back to our list of defaults. And I can now minimize this, and I'll cancel out of this for right now. And now if I pick a hole, like let's say this first hole, let's say this one down inside the part. The first hole will be easy because it's at Z0 already. I'll grab this one, and I'll go up and select drilling. Now when I do, take a look at what full clearance is set to right now. Full clearance is now a value of 0.25. Okay, 0.25. Now where does it get that 0.25 from? Well, if I look at that hole feature, I know that if I look down in my location under my starting point, the starting point of that feature is at z minus 0.75. So what it did was it simply added 1 inch to that value. So by adding 1 inch to that value, my value that I end up with in my operation is 0.25. Right? So my logic is working. If I grab the first set of holes on the top and I go into my drilling again, it's 1 inch. Let's test this. Let's take this hole and let's go out and do a right-click copy and I'll translate and I'll move it Z plus, say, 2 1/4 inches up in Z. So now it's up here in Z, right? Now I'm going to take that whole feature and go into drilling. And when I do, I now see my full clearance says 3.25. So you see what's happening is the logic that says get the extremity of where the feature is in Z. Where does it start at in Z? And add, if I'm in inch, 1 inch. If I'm in metric, add 100 millimeters. Going to hold our shift key down, pick the bottom face, we group them all, and let's click on pocket. It picks a pocket, and we now go to the bottom, we see that it just simply says pocket again. Now I can grab the pull down and change it manually to open pocket. That's really not what we need to see, is it? So it's wanting to see this as a pocket, because it really in essence it is a pocket. So our recognition rule here of is open pocket is a little bit weak. It's really not going to accomplish what we want. Now how else can we designate this as an open pocket separate from the big pocket that we're cutting? Well, we might look at size. You see the area of this pocket is only 470 thousandths. It's fairly small. The area of this pocket is 8 inches. All right, so we certainly could look at an open pocket with regards to area and use that as a as something to help us recognize this. So we could actually take the recognition that we're using. Also, let's look at the pocket. The direction, it is showing it to the inside, so that is the same kind of rule that we have for pocketing. So what we might look at is we might look at adding to our pocket that we already have, features closed and feature removal equals 0, and we might look at under object feature area as, let's say it's a certain value, let's say it's greater than let's say it's greater than an inch. And okay, and I'll copy this actually. Okay. And now under my open pocket, I'm going to edit this recognition rule. I'm going to group over top or highlight this, and I'm going to do a right click and a paste. And I'm going to say if it's less than or equal to 1 inch. So we're going to use the same recognition, but we're going to say if it's less than or equal to an inch, it's an open pocket. Let's go test it. Delete the pocket, hold my shift key down, pick the feature, and let's click on pocket and click on pocketing. Now we got a pocket. Now let's see what kind of pocket it thinks it is. It's an open pocket. Does that mess up our pocket that we did earlier? Well, let's find that out. Let's just delete this part and the pocket, and let's just recognize those items. Let's pick here the loop, and let's look at the pocket. Should still say pocket. It does. It doesn't say open pocket. The boundary still says face milling. And if I hold my shift key down and pick this feature, and if I hold my shift and control key down and pick the bottom of the other open pocket, should be able to hit pocketing. Should get 2 more pockets, and they should both be open pockets, and they are. So you can see now they're both open pockets. So now we go in and we can now add to the open pocket, we can now add a process. We can add a new process. We can call this an open pocket. Now, of course, from here I can open up my saved operation. Again, we can open that up if I want to do any editing to it. I can edit this. It's going to be using, in this case, a 1/2 inch end mill. All right. I can make any edits I might want to make. Now I can pick both of those pockets and now go up to Common Machining, and I can now go into Process Manager. Now we'll find an open pocket process, and we'll see our open pocketing process underneath each. So we hit apply, and we now should get 2 open pocket operations. Undo it. So now if we pick our boundary, our pocket, and all the pockets, we should be able to launch the Process Manager. It's going to now recognize the features. Oops, drag us up here. There's our boundary, there's our pocket, there's our 2 open pockets. Now we hit apply. It's going to apply all 4 features and create all the operations necessary to cut the part. And of course load the tools in that weren't there. Let's test that tooling thing. Let's get rid of these tools real quick. Delete them. So there's no tools in this file either, just the features. Pick all 4, Process Manager. and it recognizes it. There's all my operations and features. Apply. Done. Excellent. So now we've taken care of, at this point, all the recognition needed to do our milling on this part.